A warm welcome to all inquisitive audience. Today we are going to have brainstorming session on Griha, that is Green Rating for Integrated Habitat Assessment. Let's start with the session. The sequence of our presentation would be, first would be introduction, then green buildings overview, that is history, how green rating has come into current use, different types of rating and agencies, then Griha and its variants, then the professionals involved in design of green buildings, then cost economics of green buildings, and finally we'll be dealing with design principles of green buildings. The introduction. Since the Industrial Revolution, the world has witnessed immense technological achievement, population growth and increasing resource use, which has led to the side effects, which includes pollution, toxic waste, global warming, resource and ozone depletion, and deforestation. All these efforts are straining the limit of Earth's carrying capacity, its ability to provide the resource required to sustain while retaining the capacity to regenerate and remain viable. Here we are talking about sustainable development. Since we are covering Griha, which is linked to construction industries, we are more focused on construction related activities. The construction industries are contributing to 60% of the fresh water withdrawals, as we can see in the bar chart. For timber harvest, it's 25% of the contribution, then raw material consumption 30%, global carbon dioxide emission 35%, global energy use 40%, municipal solid waste to landfills 40%, and ozone depletion, that is 50%. So there was need for green ratings. And for achieving green rating, the building need to be green. And what is a green building? So the building which makes the greatest possible use of natural light and air, which utilizes least non-renewable electricity and water, which uses industrial byproducts, which emphasizes on recycling of wastewater, which harvests rainwater, which utilizes air conditioning to least possible less production of carbon dioxide, and overall the building which tries to safeguard the environment in every possible way. So what is green building rating system? Who certifies it and how the rating is done? In 1993, US GBC, that is Green Building Council, was established, and under that a LEED, that was an initiative taken by US GBC, which is a non-profit organization and driven by different members of construction industries. The LEED was created to facilitate positive results for the environment, occupant health and financial return. That defines green by providing a standard parameters for measurement, and that prevents greenwashing. Now what is greenwashing? Basically, greenwashing is the use of marketing to portray an organization products, activity or policies as environmentally friendly, which they are not. The act of greenwashing, also known as green sheen, entails the misleading of consumers about the environment benefits of a product or policy through specious advertisings. The technical overview of LEED. Green building rating system currently is available for any new commercial or institutional constructions or any major renovations. It evaluates and recognizes performance in accepted green design categories. LEED product developments include existing buildings, commercial, interiors, multiple building and habitat. The whole building approach, actually LEED utilizes whole building approach, and it encourages and guides a collaborative integrated design and construction process. It optimizes environment and economic factors. There are totally 4 levels for LEED certification: certified level, silver, gold and platinum. And these ratings are given in 5 different categories, that is indoor environment quality, which contributes to 25%, material resources, that is 20%, energy and atmosphere 27%, and water efficiency 8%, and sustainable sites, that is 22%. So USGBC was basically a US initiative, and on similar model we have introduced Indian Green Building Council, which was also a non-profit organization initiative taken by CII, that is Confederation of Indian Industries, and Godrej Building Green Business Center, which is actively involved in promoting the green building movements in India. It is using India's LEED rating system, which is very similar to US GSBC LEED norms. You can see this is a building, that is IGBC headquarter at Hyderabad. This was the first LEED platinum rated green building outside USA and third in the world. And then we come to Griha. The previous both were USGBC and IGBC were non-profit organization, but our government under Ministry of Renewable and Renewable Energy has launched Griha rating. This was initially conceived and developed by TERI, the Energy and Research Institute. It is an indigenous green building rating system of India, which is suitable for all kind of buildings in different climatic zones of the country. Griha ratings are available in different 7 categories. We have Swagriha, Griha, Griha for affordable housing, Griha for existing buildings, Griha for day schools, Griha for large developments, and Griha for cities. Swagriha. Swagriha is an abbreviation for simple, versatile, affordable Griha, and it was conceived to spread out the concept of green buildings to small scale stakeholders, that is owner of the projects such as bungalow and small offices. All the construction which are having built up area ranging from 100 meter square to 2500 meter square are eligible for certification under Swagriha version 3. Now what is version 3? There is technological development which are being introduced in terms of different versions. Now we are currently following Swagriha version 3. Previously we had 2 versions which are now outdated, and we are following currently version 3. The rating system has 7 environmental sectors based on which a project is evaluated. The total points that can be achieved from these sections are 50. These are the rating systems. We can go up to 5-star ratings for 45 to 50 points. Then comes the Griha. Any building having built up area for more than 2500 meter square, excluding parking, basement and typical buildings, are eligible for certification under Griha version 2019. This is 2019 version. This rating has 10 environmental sections with 29 criteria based on which a project will be evaluated. The total points that a project can achieve from these sections are 100. Now these are the different sections. There are totally 5 sections. I am covering one by one. This is 5 sections, and in next slide we will be covering the next 5 sections. So under these 5 sections we have different criterias. Each section have 1 to 4 criterias. So the first is green infrastructure. There we can achieve 5 points. Then low impact design. Then design to mitigate UHIE. Now what is UHIE? This is an urban heat island effect, which is an urban area or metropolitan area that is warmer than its surrounding rural areas due to human activities. So how do we mitigate that? Based on that we can achieve up to 2 points. Then air and soil pollution control under construction management. These are basically management techniques which we use during construction. There we can achieve maximum of 1 plus 1 plus 2, 4 points. Then we have energy efficiency. Here we can see in energy optimization we can achieve up to 12 points. Renewable energy utilization 5 points. Then low ODP and GWP materials. GWP means global warming potential, and ODP ozone depleting potentials. So we have to use low ODP and GWP materials, and in that we can achieve 1 point. Then visual comfort, thermal and acoustic comfort 2 points. Maintenance good indoor air quality 6 points. Water demand reductions, wastewater treatment, rainwater management, water quality and self-sufficiency 5 points. Here you can see most of the criteria knowingly or unknowingly we are following in our designs, but with slight improvement we can go for rating also. Another 5 sections are soil waste management, that is waste management post occupancy 4 points, organic waste treatment on site 2 points, utilization of alternative material 5 points. So likewise we can achieve up to 100 points. There are some criteria which is obligatory, which does not give you any point, but that has to be fulfilled to go for registration under Griha, that is smart metering and monitoring system and operation and maintenance protocol that has to be monitored for any registration under Griha. Now this is the scoring point for Griha. Now who are the professionals involved in design and construction of green buildings? The traditional project team includes owner, project manager, architect, HVAC, that is heating, ventilation and air conditioning engineer, plumbing, fire protection engineer, electrical engineer, lighting engineer, structural engineer, landscaping specialist, civil engineer, code enforcement official, construction manager. These are the traditional team. Now for a green design, who are the other specialists involved? The one is energy analyst. They do analysis by using some typical or standard softwares. Then environment design consultant, then green rating facilitator, commissioning authority and building operator. Now the cost economics of green building. Construction industry is big industries, and everywhere all industry means business. For business we have to justify the economics. So we have taken around 7 buildings and found out how the extra expenditure incurred for getting green rating are being paid back. So the first building, that was the IGBC headquarter, platinum rating was awarded in 2003, and you can see the built up area was 20,000 square meter, and there was increase in cost of 18% in that, and that cost was recovered in 7 years. That is, by 2010 they would have recovered all the extra expenditure incurred for getting the green ratings. So similarly, we have taken 6 buildings, and as you see, every passing year we are able to get that payback extra expenditure amount in less than 5 years, and generally the building is designed for 50 years. Within 5 years, that is 10% of the design life, you are able to get that extra expenditure incurred for green rating. That is huge achievement. Now, what are the design principles for green buildings? As we have already seen, energy efficiency contributes to 12 points. So we are taking not 100 points, we are just seeing how we can improve the energy efficiency of building by making slight modification during architectural design, during structural design, during plumbing designs. For seeing the green building, different parameters have been considered. We can make certain corrections using orientation, glazing, insulation, daylighting, equipment. So for that we have to take some hypothetical office. We have assumed a building of around 50,000 square meter of geometry, G plus 10 floors, and say the building is in Delhi. All these analyses are being carried out in a typical software called spectral software, and this is the screenshot of that software. So for traditional building of this geometry, the AC load was 1029 TR, and water chilling machine 3 number 450 TR, electrical load 1600 kilowatt, transformer required was 2 numbers 1250 kVA, DC selections 2 number 1250 kVA. So how we can achieve optimization? Just by orienting the building for having maximum sunlight, we can achieve saving in energy by 1%. This was the orientation, we have changed it to north-south direction, and this is the orientation. We could achieve saving of 1%. Second, roof insulation. Roof insulation can be overdecked or underdecked, and by this we can achieve up to 1% energy efficiency. So you can see this small table. This was the conventional energy requirement. After making improvement in orientation, that is last improvement, we could achieve, here you can see 4527 energy megawatt hour requirement to 4526 units, and from this, from current improvement in roof isolation, we can achieve 4463 requirement in megawatt hours. In cooling load also we could achieve from 1097 to 1030. In carbon emission also we could see slight improvement. This is just the second improvement. Third improvement is wall insulation. Previously we have seen roof insulation, this is wall insulation. In wall insulation we could achieve slightly better, that is 1.5%. Then glazing, there are two types of glazing, that is single and double glazing. Here glasses comes with different coefficients. One is SHGC. What is SHGC? That is solar heat gain coefficient, and it is the amount of heat from direct sunlight that passes through glass. This includes sunlight which passes directly through the glass to the room, and the amount of sunlight which is absorbed by the glass and later re-radiated to the room. And the optimum combination is HSGC of 0.33 for doubly glazed glass. And what is VLT? VLT is visible light transmittance, and it describes the percentage of visible light transmitted through the glass. It is determined by the glass color and thickness. Clear float glass can have VLT of from 75 to 92%, and color glass can have from 14% to 85% VLT. So we can see by changing glazing to this parameter, this coefficients, we can get massive improvement of 2% of energy requirement. The next is improvement in shading devices. Shading devices can give saving up to 5% by fins and overhangs, and this improvement can be done during structural and architectural design itself. As you can see, from 4527 unit requirement of energy usage, we could achieve saving from these 5 improvements. These are the examples of shading devices. These are the fins, these are the different kind of chajjas. This kind could be achieved in architectural and structural design itself. This is again the shading device example. Now next improvement is wall to window ratio. Generally we go for 60% wall to window ratio, but changing from 60 to 40%, we could achieve energy saving up to 5%, and this is huge achievement. As you can see, this is a general 3D view of building. From this to this, we could achieve energy saving of 5%. These are some of the fine examples for optimum wall window ratios. And next is daylighting. The location of window and dimensions of window are kept such that maximum daylight could be achieved at the interior most point of the room. And as you see, these are the different lux, and this is the optimum range around 500 to 705. The lux of 900 is not pleasing to the occupant, and 250 is very considered to be very dark room. So this is the optimum value. By changing the window size, dimension of windows, we can again achieve some energy efficiency. Daylighting controls, this is again electronic equipments which can be used, already being used in markets, lux level sensors and occupancy sensors, and from this we can achieve saving up to 8%, again a huge saving. You can see these are the office rooms which does not have any non-renewable energy sources. Next is lighting power density. Lighting power density technically represents the load of any lighting equipment in any defined area, and by changing LPD from 2 watt per square feet to 0.8 watt per square feet, we could achieve saving of 3%, a huge saving. This also represents the uniform distribution of lights in a particular room. Again, use of CFL, LEDs are also part of LPD improvements. Then installing VFDs. VFD is basically a type of motor controller that drives an electronic motor by varying frequency and voltage of its power supply. And by this we could achieve 5% saving in energy efficiency. And VFD generally in building we are using it in AHUs, pumps and cooling towers. 35% of energy has been saved using this slight minor changes. Then 10th is economizer. Economizers are heat exchangers that transfer the heat in the flue gas to another medium. It increases the efficiency of any equipment. It is different from AHU, chiller and boiler. And by using these economizers, we can achieve saving of 2% of energy requirement. Next is better chiller. In chiller, we can have better coefficient of performance. And changing that coefficient performance just by 0.6 points, we could achieve saving of 5% energy requirement. Pre-cooling fresh airs. This is again a type of economizer only, and we are achieving 3% of energy savings. After all these 12 improvements, you can see we have achieved cumulative saving of 45% of energy requirement in any building. So this is the general savings in conventional building and green building. CO2 emissions has been reduced from 2700 units to 2143 units. Cooling load has been reduced by 45%. Electrical consumption has been reduced from 4500 to 2500 megawatt hours. That is a huge reduction in energy requirement. The DG set has been reduced from 2 numbers 1250 kVA to 2 numbers 1000 kVA. Transformer rating has been reduced from 2 number 1250 kVA to 2 numbers 1000 kVA. Okay, these are the improvement we have done in terms of energy efficiency. There are certain other improvements we can do and which are very generalized in nature. We can insulated roof systems by creating roof gardens, insulating exterior walls, double glazing windows and curtain walls, fixing low flow water fixtures, using fly ash based block machinery, reducing heat islands by providing more than 50% of parking under the building, use of treated recycled water for gardening, arboriculture and flushing, rainwater harvesting, constructing SWTs, storage and collection areas for recyclables, indoor air quality can be enhanced by using low VOC paint, that is volatile organic content paints. Building shall be declared as no smoking zone, light pollution reduction by specifying fixtures that eliminates light trespassers, reducing power consumption by using proper LPD based on space requirement by space method, using CFLs, LED lightings and using electronic appliances having star ratings and using economizers. So these are the general overview. Thank you for having a patient hearing.